So today we're going to continue looking at graphs of quadratic functions used in completing the square, but this time we're going to be looking at maximum turning points. So previously we looked at examples where we just had a minimum turning point. So we've got a standard parabola where it's reaching a minimum turning point, and we were using the equation completing the square form to help us identify things like turning points and also axis of symmetry. So we've seen this example before, where the turning point is 4, -2, and it is a minimum turning point because it's reaching the smallest height of the graph. And we know that the turning point is AB. And we can use that to help us form an equation for this parabola, because we know that we change the sign of A. So if A is 4, we change the sign to put it into our formula. So we've got -4 here. And for B, we just leave it alone to get -2. And we also discussed that if you know A, you know the axis of symmetry is x equals A. So in this case, A is 4, so our line of symmetry is x equals 4. And this has to be an equation. You can't just write axis of symmetry equals 4. It needs to be an equation, x equals 4. So this was minimum turning points. And today we're going to be looking at maximum turning points. So this time we've essentially got an upside down parabola where it's reaching the highest point. And that is going to be the turning point. So this time we've got a slightly different expression for it, completing the square form. Y equals b subtract x minus a all squared. It essentially looks like these two parts have been swapped around. But what this actually looks like, we could rewrite it to be y equals negative x minus a all squared plus b. So that looks much closer to the form that we were dealing with before. But this time we've just got this negative in front of it. Because if we multiplied this out, we would get negative x squared. And you know previously from working with quadratic graphs that negative x squared is a parabola that is upside down, essentially. So if we were to multiply this out, we would get negative x squared, and that is why we're getting a maximum turning point. But just to make things a little bit nicer, rather than starting the equation with a negative, we've just brought that b forward. So we've got the positive value first, b, subtract, and then x minus a all squared. So you could see it in either forms, but we're going to be working with this one here today. We're just going to be using the same steps as we've done previously, but we're just going to be using this new form. So we know the maximum turning point is 3, 5, and it's a maximum turning point. So we know that A is equal to 3, and we're going to do the same thing where we're going to change the sign to put it into our formula. And we know that B is 5. Again, same thing, we're going to be leaving it alone. And now using our new form, we would have the equation y equals 5 subtract x minus 3 all squared, where we have changed the sign of the A, and we've just left the B alone. So that's the same steps that we've done previously. But let's just look at where this graph comes from. So like I said, we're starting from, this is a standard graph for negative x squared. And what's happening in the bracket here, we're subtracting 3, which means we're moving right along graph 3 places. And then we're moving up 5. Okay, so this is where this equation of the parabola comes from. And we can also identify the axis of symmetry straight down the middle of the parabola. We know A, so x is equal to A. In this case, A is 3, so our equation is x equals 3. Okay, now let's look at another example. So things we've picked up so far, turning point is still AB, and the axis of symmetry is x equals A. So find the equation of this parabola, and we know that we're going to be putting it in this form here because we've got a maximum turning point. So -2, 4 is a maximum turning point at AB. So if we know A is -2, when we put it into our formula, we're going to change the sign. And we know B is 4. So we're just going to leave it alone and stick it straight into our formula. So to create our formula, our equation, we have y equals 4 subtract x plus 2 all squared. So we've changed the sign to make a plus, and we've kept the 4 the same. And then to find our axis of symmetry, straight down the middle, x equals -2. Okay, let's look at another example. So this time we are just wanting to, from our equation, identify the turning point of the graph. So we're not going to see the graph, we're just being asked to identify the turning point. So our A value, we're going to change the sign, and for B, we're going to leave it alone, which makes our turning point -4, 7. And it's important that we identify and write down if it's a maximum or a minimum turning point. In this case, it is a maximum. If there's a negative in front of your bracket, it means it's a maximum turning point. And this is called the nature of the curve. And the axis of symmetry, because we know A is -4, we can write down our axis of symmetry, x equals -4. And remember that the axis of symmetry must be written as an equation. You can't just write symmetry equals -4, it must be an equation like this. Okay, your turn. For each of the following functions, identify the turning point and its nature. So by nature, I mean, is it a minimum turning point or is it a maximum turning point? So state the turning point and is it a minimum or a maximum? And for part B, for each one, can you please write down the axis of symmetry? So pause here and give these a go. Okay, so for the first one, to find the turning point, we've got our A and our B. For A, we need to change the sign to make it a +4, and for B, we're going to leave it alone. And because we've got a negative in front of our bracket, that means we're going to have a maximum turning point. So we've got 4, 7, and a maximum turning point at 4, 7. And because we know A, our axis of symmetry is x equals 4. For B, we don't have a negative in front of our bracket, which means this is a minimum turning point. We know A is 2, so we're going to change the sign of this to get A as -2 and B is 3. So we've got a minimum turning point at -2, 3. And because we know A, we know that the axis of symmetry is x equals -2. For C, we've got a negative in front of our bracket, which means this is a maximum turning point. We've got -5 here, change the sign to get +5 for A, and we've got -1 as B, which we're going to leave alone. So we've got a maximum turning point at 5, -1. And because we know A, which is 5, our axis of symmetry is x equals 5. And for D, we've got +3 here, change the sign to get A, which is -3, and we've got -2 as our B. And we've got a negative in front of our bracket, which means this is a maximum turning point. So we have a maximum turning point at -3, -2. A is -3, which means our axis of symmetry is x equals -3. So excellent work if you got all of those correct. Okay, this time I would like you to use the turning points to write down the equation of each graph below. So pause here and write down the equation of each graph. Okay, hopefully you've unpaused now and we'll go through the answers. So A, we've got a maximum turning point at 7, 2. So we know we're going to have a negative in front of our bracket, and we're going to change the sign of the A to get -7, and 2 is going to be kept the same. So we're going to have y equals, this is round the wrong way, this should say y equals 2 subtract x minus 7 squared. Ignore that one. Okay, so your B comes first, 2 subtract x minus 7 all squared. Okay, next one, we have A is -3, so we're going to change that sign to give it a +3, and our B is going to stay the same. So you should have y equals 5 subtract, because it's a maximum turning point, we need a negative in front of our bracket, subtract x plus 3, because we've changed the sign of that -3. And on to C. So our A is 6, so we're going to change the sign to be -6. We're going to keep B the same. Again, we've got a maximum turning point, which means we need to have negative in front of our bracket. So we will have y equals -1 subtract x minus 6 all squared. And the last one, a is -1, so we're going to change that to a +1, and we're going to keep -3 the same. It's a maximum turning point, so we need negative in front of our bracket. So we should have y equals -3 subtract x plus 1 all squared. Again, excellent work if you got all of those correct.